Hello, today's lesson is on multiplying probabilities. A compound event consists of two or more simple events, where a simple event might be rolling a die or flipping a coin. If it is compound, it consists of two or more simple events, such as flipping a coin twice or flipping a coin and then rolling a die. When finding the probability of compound events, we must first find the probability of each simple event individually. So this section is going to focus on using the multiplication rule. To find the probability of a compound event, we multiply the individual probabilities of each simple event. The rule that we need to understand and remember is that the probability of A and B is equal to the probability of A times the probability of B, and is called the intersection. You might remember us using the symbol intersection. This is the same thing. So let's take a look at the first example. Let's say Raheem chooses a soda from a cooler that contains 8 regular and 5 diet drinks. He decides that he doesn't want one, so he puts it back. We want to find the probability that Raheem and the next person both choose a regular soda. Let's first make a tree diagram to illustrate this example. So the choices are regular and diet. There are 8 regular and 5 diet, with a total of 13. We can actually place the probability of choosing a diet or regular right here on our tree diagram. So note that the probability of choosing a regular soda is 8 out of 13, while the probability of choosing diet is 5 out of 13. Now let's say he chooses a diet first, and then, remember, he decides he doesn't want that one, so he puts it back. So that means on the second time that he reaches in for a soda, he could get a regular or he could get a diet. There are still 13 sodas in the cooler, 5 of which are still diet and 8 still regular. Remember, this second branch represents the second time he pulls out a drink. So see how we can put the probabilities right there on the diagram. If we want to find the probability that he pulls out 2 regular drinks, all we would need to do is multiply the 2 probabilities. So the probability of choosing a regular, put it back, and then choosing another regular would be 8 out of 13 times 8 out of 13, or equal to 64 over 169. If we wanted to find the probability that he chooses a diet, puts it back, and then gets a regular, we would multiply the probability of choosing a diet times the probability of choosing regular. 5 times 8 being 40, 13 times 13 is 169. So we just multiply those probabilities. So that's a compound event, taking a drink and then taking another. So the slide asked, how do you know that this is independent? Well, we have talked about when events are independent and dependent, and we know that if something is replaced, then that is an independent event. If it was dependent, then this second time we would only have 12 drinks, either of 12 drinks total for these probabilities for the second part of this tree. So therefore it is independent because it is replaced. Next, we need to understand total probability. The total sum of probability of a sample space is always equal to 1 or 100%. Remember we had talked about, we can actually illustrate this here on our tree diagram. If we add 8/13 plus 5/13, remember that when we add fractions with the same denominator, we add their numerator, then our probability has a sum of 1. So that's what we're saying, is that each branch they need to add up to 1. Same as here. 8/13 plus 5/13 is equal to 1. 8/13 plus 5/13 is equal to 1, or 100%. To find the complement, which means the probability that an event will not happen, we subtract from 1. For example, if we knew that there were 13 sodas in the cooler, and we knew that 8 of them were regular, if we did not know how many were diet, but we knew the total, we would know that the numerators for this probability and this one must add up to 1. So we can just subtract. So if we did 1 minus 8/13, or 13/13 minus 8/13, that would be equal to 5/13. So it's kind of working backward. So this would have been the complement. Okay? The symbol for a complement is A in this superscript C, so it looks like A to the C power, read as the complement of A. Let's move on to our next example. In a certain board game, 3 dice are rolled to determine the number of moves for a player. Find the probability that Consuelo rolls a 6, then another 6, then anything but a 6. To find these probabilities, we would need to consider the probability of each simple event individually. So if she first rolls a 6, we know that there are 6 possible numbers, 1, 2, 3, 4, 5, and 6. The probability that she rolls a 6 is 1 out of 6. The probability that she rolls anything but a 6, we can think of as the complement. So the probability of the complement of 6, meaning anything but 6, would be 5 out of 6. Notice how these two probabilities, and I don't know why I put A, sorry, that should be P. 1 6 plus 5 6 will equal 6 6, which is again equal to 1. So if we want to find the probability that Consuelo rolls a 6, then another 6, then anything but a 6, we simply multiply their probabilities. So 1 6, then rolls another 6, then anything but a 6. There are 5 numbers that are not a 6, 1, 2, 3, 4, and 5. If we multiply that together, we get 5 out of 2, 16, and that would be our probability. So I want you to think, is this compound event independent or dependent, and why? Well, this would be independent because the result of rolling a die the second time or third time has the probability has no bearing on, or has nothing to do with what we rolled the first time. So this would definitely be an independent event. Next, let's take a look at example 3. Say we have 12 marbles in a bag, and after each draw, the marble is replaced. So you should be thinking, well, is this independent or dependent? Because it is replaced, we know that the probabilities will be independent, which means each draw, there are still 12 marbles in the bag. So let's say we have 6 yellow, 2 blue, and 4 purple. And let's use that information to find the probabilities asked below. Well, if we have 12 marbles in a bag, we know that the probability of drawing a yellow is equal to 6 out of 12. The probability of drawing a blue is 2 out of 12, while the probability of drawing a purple is 4 out of 12. Remember what this means. This means what's the probability that you'll draw a yellow or blue? Yellow and blue. Yellow, then a blue. Remember, you're drawing 2. So I'll number these 1, 2, and 3. And over here, we'll do our work. So the probability of a yellow was 6 out of 12. The probability of a blue was 2 out of 12. Remember that when multiplying fractions, again, we multiply the numerator. So 6 times 2 is 12. 12 times 12 is 144. And that would be our answer. For number 2, the probability of a purple is 4 out of 12. The probability of blue, 2 out of 12. Multiply that, 8 out of 144. And lastly, 3, the probability of drawing a blue, 2 out of 12, a yellow, 6 out of 12, and a purple, 4 out of 12. Multiply 2 times 6, which is 12, times 4 is 48, and 12 times 12 times 12 is 1,728. And that would be our probability. And that's just applying the multiplication principle. Lastly, let's look at example 4, where we must now find the missing probabilities. So please remember that back on slide 1, 2, 3, 4, 6, it says the total sum of probability of a sample space is always 1 or 100%. So there, if you take a look at the first event, so this is a compound event because we have one event happening, then another event happening. So if we take a look at the first one, the sample space, we have 2 scenarios. To find the probability here, labeled A, we need to remember that this must have a sum of 1. So if we say 1 minus 0.45, and if you think about money, it actually helps. So think about $1 minus 45 cents is 55 cents. So that's A. Likewise, even after this happens, these 2 probabilities, these 2 events will occur. So that means that these have to have a sum of 1 also. So to find B, we would say 1 minus 0.16, or think about it as $1 minus 16 cents. And that would be 0.84. For C, actually I'm going to skip C for a minute and come down here and do F. To find F, since we were on this branch of the tree, let's do 1 minus 0.32, and that would give us 0.68. Now if you notice, right here, it's easier to see if you look on the slide, the probability of A then F is 0.374. So I'll write that a little bit bigger. 0.374. we next need to be able to find these right here, C, D, and E. Remembering our multiplication rule, we can find the probability of this event followed by this event by multiplying their probabilities. So it's helpful to go ahead and fill in what you have found thus far, because we can actually prove that 0.55 times 0.68 is equal to 0.374. So if I want to know the probability here of A, then this 0.32, I found was 0.55, so if I multiply 0.55, so for E, I'm going to put 0.55 times 0.68, and that would give me a probability of 0.176. Now, if I multiply 0.45 times B, which I found to be 0.84 earlier, remember, because these added up to 1. If I multiply 0.45 times 0.84, I end up with 0.378. And please carry it out to 3 decimal places if it goes that far. Then lastly, C, if I multiply 0.45 times 0.16, I end up with 0.072. So one thing I want you to see, if I put out here 0.072, D was 0.378, and E was 0.176, all of these add up to 1. And I'd want you to test that out in your calculator. So remember here, 0.45 plus 0.55 equaled 1, 0.84 and 0.16 was equal to 1, 0.32 and 0.68 was equal to 1, and at the end, remember, that's how I've asked you to identify how many you have in your sample space. Remember, count all of how many you have at the end. So all of this, we add up. So 0.072, 0.378, 0.176, and 0.374 all add up to 1. And that concludes our lesson. So please remember that for the multiplication rule, we simply multiply the probabilities of each simple event to find the probability of a compound event. Thanks, guys.